Well, hello C++ programmers. Brian Malloy here, and this is part 2 of my discussion on Lambda functions. And in this video, I want to focus on capture clauses. So what I have here is a good reference for Lambda expressions, Lambda functions, the CPP reference. And if we come down here, you'll see some rules for capture clauses. And these rules basically say that if a variable is non-local, you don't have to capture it. Which means, of course, if it's local, you do have to capture it. If it's a constant expression, you don't have to capture it, and so forth. So we're going to use these rules right now. I'm going to try to demonstrate them here. So let me just iconify this baby and bring this up, and let's start looking at this. So I have a little example that I've started that I hope will kind of illustrate some uses of capture clauses. So I have a global variable x. I have a variable y that's local to main, a constant expression z that's local to main, and I wrote a little lambda function that I call, oddly enough, capture. And the capture clause is empty. Why? Because x is a non-local variable. I don't need to capture it. Let me see if I can prove that to you. I'll make this. And we get some warnings because we're not using y or z. So I'm not using the variables that I declare y or z, so the compiler says, why don't you use them? But I print global variable 7. And likewise, since z is a constant expression, if you read the rules on CPP reference, you'll see that you can also access a constant expression if it's local z. So I should get 17 here, and I do. However, I have a variable that's not constant expression. It's local. Y is local. So if I try to use local, if I try to use y in this lambda function body, I'm going to get I hope, a lucid error message that says, let's see, what does it say? Y is not captured. We got to capture it. My dog wants to play. No, not now. Okay, so let me just take a look here. So what we got to do is capture it in the capture clause, and we're going to capture it by value because we're not changing it in there. If we were changing it, we'd have to capture it by reference, and we get the local variable here. So not a ringing endorsement for capture clauses, but it kind of demonstrates some of the rules that you can read about on CPP reference. Let me just mention one other thing about capture clauses. There are some wildcards I can use here. You can look them up on CPP reference. I think it's equals and ampersand, I believe, or maybe it's equal and star, that will capture everything by reference or everything by value, whichever you prefer. And there's a lot of other things you can do in a capture clause, but I just want to give you some fundamental rules to follow here. Let me see if I can give you a better endorsement for capture clauses. So let's write a recursive function, and we'll go with the old standby factorial. So let's write it wrong first, and maybe it'll illustrate something. Let's write function fact. Okay, we'll call it fact, and we won't capture anything in the capture clause. Let's see. What am I doing here, you're wondering? Okay, so let's write factorial, and it's the standard old factorial. We'll pass parameter x in here. Why don't we call it n just for the heck of it? And what we'll say is if n is 1, we'll return n. Otherwise, we'll return n times fact of n minus 1. Okay, now this is not going to work, of course. Wait, let me just come down here and get rid of this, and let me print fact, say of 5. And why won't this work? Well, because we have a name we're using here, fact. We're using the name fact. And we're also using it in this declaration here. We're kind of declaring fact. So the compiler is trying to deduce what this is to figure out what the auto stands for, and it can't do it. So let me just show you what I mean. Let's see what kind of an error message we get. Compile it, and it can't deduce what it is. It just can't deduce what fact is. Okay, so what do we have to do? Let me do it the right way, and then we can take a look at it. So what we have to do, actually, we can't use auto. I'm going to show you why you can't use auto. We have to tell it it's a lambda function. Let me see if I can spell it correctly. That returns an int, accepts an int as a parameter, and its name is fact. Okay, so I've declared a name, fact, local to main. All right, so I've declared a name fact, local to main. And since it's local, I've got to capture it, and I'm going to capture it by reference because I'm going to use it in the return values with it. So here I am. I'm using a name fact in the function body, and it's a local It's a local variable, so I have to capture it in the capture clause. And now we can compute our time-honored factorial. Let me show you that this works. There you got it. We've just computed factorial. Kind of fun, I guess, in a way. I don't know. Now, and you might say, oh, gee, I just love auto. I got to use auto. Well, you just can't figure it out. Watch. Suppose I say auto fact. I mean, no compilers can figure out. Even Python. If you just say X, let's just put X. The compiler can't figure out what X is. I mean, you have to say X equals 5. And then the Python compiler would say, well, it looks like an int, it quacks like an int, it walks like an int, we'll use duck typing and say it's an int. But here we don't have any clues about what this fact is. So we can't use auto here. We have to actually do it the hard way. So there are times when auto doesn't work. I guess that's the lesson here. So what am I trying to show here? I'm trying to show that if you want to write certain kinds of functions like a recursive function, and they are handy sometimes, not factorial isn't, but there are some that are handy. You may have to do it the hard way, declare the name so you can use it in the Lambda function body, and then since it's local, you'll have to capture it in the capture clause. So that's Lambda function capture clauses. Kind of the basics rules. If you want more information, especially about the wildcards you can use in the capture clause, look it up on CPP reference. Hey, happy programming. Brian Malloy, over and out.